All right, so we're going to look at the sums and products of sine and cosine. So some of the prior knowledge you need for this is lecture one, where we spoke about circular functions, and that is having a good grasp of that is going to be important for this. But also lecture 15, where we spoke about compound and double angle formulae. So the key concepts we'll cover in this are the product of some identities. So if you get given some product of two trigonometric functions, and you want to convert that to be the sum of some trig functions. We're going to look at that, and then we're going to look at going the other way around. So the sum to the product of some trig identities. So let's jump into it. We'll give some proofs of them as well. So let's have a look. So if we want to go from a product to a sum, what we need to actually do is we need to use the compound angle formula for sine and cosine. So again, I'll put the link below for that. But if you can recall the compound angle formula, this is two of them. There's four in total, but these are the two compound angle formulae. And what we can do is we can use this information to come up with our first product to sum identity. Okay, so let's maybe just look at the first product to sum identity. It says 2 multiplied by cos x by cos y equals cos x minus y plus cos x plus y. Okay, I think you would agree that if we were to add equation 1 and equation 2, on the left-hand side, we would get cos x plus y plus cos x minus y. Okay, so you can see that that would match the right-hand side of this equation here. And similarly, if we had the right-hand sides now, cos x multiplied by cos y minus sine x by sine y. If I add that to this here, what we're going to get, what's going to cancel out is the signs, because minus sine x by sine y plus sine x by sine y are going to cancel out. And so we're going to be left with two groups of cos x multiplied by cos y. So that's the left-hand side. So 2 cos x cos y equals cos x minus y plus cos x plus y. So that is our first product to sum identity. Now, similarly, the other two product to sum identities can be found using the other compound angle formula, but it's pretty much the same logic, so we won't bother doing it. Now, the other thing I'll just mention is that, yeah, product to sum. We can see that we've got a product of two trig functions, cos x multiplied by cos y, and it gives us this, which is now the sum. Okay, and what I wanted to do as well is do a demo. So over here, we've got all this colorful stuff going on. Let me just explain. This angle in blue, I can't really click on it, but in blue here is angle X. This one that's in pink here, or magenta, or pink, is angle Y. All right, cos X minus Y. So X minus Y is actually what's in orange here. This orange one is X minus Y. Yeah, so my diagram was just a little messed up there, but I fixed it up. So yeah, cos X, so X is the blue angle. The pink angle is Y. X minus Y is the orange angle. So if we take blue, take away pink, we get this orange angle here. And then X plus Y is this green angle all the way around the side here. So what we can actually see is just a demonstration that this first product to some identity holds true. So it might not be obvious straight off the bat that that all adds up, just doing it in your head. But if we pick some familiar values, if I change X to be maybe 90 degrees, I change Y to be 180 maybe, we can verify that this holds true. If I get that to 0, yeah, there we go. 2 times negative 1 times 0 is the left-hand side. That just equals 0, and 0 plus 0 is 0. So we can see that it equals, I think you can take the leap of faith there that it holds true for all these values, even here. If we look cosine of the pink angle at the moment is 0, and so we get on the right-hand side 0.9 plus negative 0.9, which is also 0. So yeah, I think that's a pretty interesting result, and that's sort of just a demonstration of what's going on there. So pretty cool looking diagram as well, I think. Okay, so that's the product to sum identities. That's how we convert from a product to a sum. Let's look going the other way. To go the other way, these are the rules that turn out to be true. And so we're just going to look at this first one and see if we can show that this is true. So what we want to do is first recall the product to sum identity from before. So literally just the one we looked at. 2 multiplied by cos x cos y equals cos x minus y plus cos x plus y. Okay, and then we can just do a quick proof here. So if we were to say that the angle x was equal to x plus y on 2, we would sub that into here. So it'd be 2 multiplied by cos x plus y on 2. And if we were to say y was x minus y on 2, we would get cos x minus y on 2. All right, equals, now just applying this rule that we just learnt. So to be cosine of x plus y on 2 minus x minus y on 2 plus cosine of x plus y on 2 plus x minus y on 2. And so what you'll notice is if you add these together, it'll be x minus x, so the x's go away. It'll be y minus negative y, so that's 2y on 2, which is just y. Similarly over here, add these fractions together, you'll get 2x on x, 2x on 2 rather. Cancel the 2 out, you're just left with cos of x. And obviously these are commutative, so we can just swap them around. So we can see that this left-hand side here equals cos x plus cos y, which is in fact our first sum to product identity. Again, similarly, these other three can be proved in a very similar way from the it's a very similar way to that by using the product to sum identity that we just spoke about. Okay, again, let's just look at a demonstration. So again, just looking at this first sum to product identity. If we were to write it out like this, again, x is the blue angle, y is the pink angle, the green angle is x plus y on 2 this time, so it's on 2 here, and the orange angle is x minus y on 2. And again, just subbing in these values, we can see that at the moment, the blue angle is 90 degrees, so cosine of 90 degrees is 0, so that checks out. But if we just change this to some familiar values, let's maybe make the blue angle 180 and the pink angle, we'll make the pink angle something like that. Negative 1 plus 0 is negative 1. 2 times yeah, sorry, that does check out. Negative 1 plus 0 is obviously negative 1. All right, negative 0.71 times 0.71 is approximately negative 0.5 multiplied by 2 is negative 1. So that does actually check out. I can assure you all these other ones will check out as well. These equations hold true. The left-hand side equals the right-hand side. Just see if I can find another one where things line up nicely. Maybe if we put that one there and the pink one here. Yeah, there we go. Negative 1 plus 1 is 0. 2 times 0 times 0 is obviously 0. So yeah, obviously that's just demonstrating the fact that it's true. But yeah, hopefully you can get some intuition for these sum to product identities. As always, if you found that useful, even if you just needed a screenshot of the information, please give us a like and get in touch if you need any private tutoring. You can visit my YouTube channel, or you can come over to my website and find my contact information here. So good luck with everything you're doing, and I'll talk to you soon.